Welcome to the video series about the computer science subject of the 12th standard Nadu State Board syllabus. This is the fourth video in the series and it is about chapter 4 of unit 1, which talks about algorithmic strategies. Before we go into this chapter, I'll give a quick brief overview of what we have covered so far in last 3 videos. If you haven't seen those 3 videos, I strongly recommend you to first watch them and then play this video after the last 3 videos. So the first chapter we discussed briefly about the functions and we slightly touched about what is an algorithm. But in chapter 4 in this unit we are going to talk more about it. As we discussed before, a function is a fundamental element for a programming language, and a function can have one or more subroutines. For a programming language to perform properly, an algorithmic statement is very important. When we discuss about data abstraction, it's nothing but a process of providing only the essentials and hiding the details, which is nothing but which allows the programmers to treat most of the code as objects. When you have a code with object definitions, it makes a programming style of writing much easier. And then when we talked about scoping in chapter 3, we really talked about multiple types of variables, expressions, parameters, and how they're all used in a function in a part of any program, and we also saw a few examples of them, and the scope of the variable, how it's visible in a local level, global level, and also sometimes in the very system level, etc. So all these topics of function, abstraction, as well as scoping, they're all basic elements of programming, right? And before we go in detail about Python in Unit 2, I think this is the last topic we are going to talk today, which is the algorithmic strategies and why and how it is used. So with this chapter, I think you will have basic understanding of the fundamentals of a computer programming. And after that, from Unit 2 onwards, we will go deep into the programming itself and the programming languages and how to use them, etc. Okay, let's go into the chapter detail. So again, in this chapter, we're going to see 4 different key subject areas. One is about its technical perspectives and its basics and definitions. And also there were topics covered about how efficiency and time and space plays a role in a programming style, and also how searching and sorting happens. There are a few types of searching and sorting methods, and lastly very short brief description about the dynamic programming approach as well. And in your book, they try to really compress many detailed topic into very short sections, but I'll do my best to explain the reason and why we are using them, and hope that will give you a basic understanding of the algorithmic strategies as well. At the same time, I've called out important points which are also very useful for your revision as well. Okay, so we'll talk about the characteristics and examples. Before which I explain what is an algorithm, I would like you to pay attention to the picture in the bottom. So you can see that algorithm is in the middle in this picture, and then when you see from left to right, there is an input and then there is an output. What does that mean? Every program will always have an input and there is an expected output. So for example, if you want to do 1 plus 2 is equal to 3, so 1 plus 2 are the inputs and then output is 3 really. And in algorithm, there will be many other characteristics surrounding it. So, for example, it's sometimes there are, when you write a program, there are like things like being you made independent. Independent style of writing is important, and it has to be very unambiguous. That means it's clear for a program to understand, the logic to understand for a computer. And finiteness, that meaning most of the time, if you want to be careful in writing a program which doesn't go into an infinite loop, otherwise the program will never finish and produce an output. And then the feasibility, meaning okay, when your problem is given, sometimes is it feasible to get the record outcome? That needs to be assessed as well when you're writing an algorithm, when you're thinking about your logic for a particular program or a problem you're trying to resolve. So an algorithm is a finite set of instructions to accomplish a particular task. Again, the simple example I would use is if you wanted to add two numbers to get an answer, that's a simple task for a computer program. It is always, when you're writing an algorithm, helps to produce a step-by-step procedure for solving a given problem. A way of designing an algorithm is called algorithmic strategy. This is important to know. So the style of solving, you design a program or design the solution to a problem is actually called an algorithmic strategy. So in computer field, if you're a programmer, uh, when a problem is given, normally a programmer will first think about, try to understand the problem, number one. After that, the method they will try to plan it is sometimes write a pseudocode, and that kind of and in which in the pseudocode they will talk about the step-by-step tasks, what they're planning to do, and that style of writing and designing is called an algorithmic strategy. And hence an algorithm really is important as a basic fundamental element for any programmer to think before you go and start writing your code in the computer. Okay. An algorithm can be implemented in any languages, any. It's just I've given you very few examples here, obviously. Java, C, C++, Python. You know, you have hundreds and hundreds of languages right now in this world. But algorithm, which is a fundamental pseudocode, is common because it describes the task and the problems, the task which we have to do to resolve a problem to get a solution, so which means the output. And hence algorithm is quite static. Anywhere you take an algorithmic code and you can say whichever program you like to implement it, it's possible, right? That's how you have to say it. It's basic. And it's very clearly said it's independent of any programming languages. And algorithms also developed to store, manipulate, and retrieve data from data structure. Obviously, you know, data structures we saw in the past, it can be stored in form of arrays, a list, or a tuples. Doesn't matter whatever method it's stored in a programming, using a programming language, but algorithms helps to retrieve such data as well, right? In the form of, by writing a programming language, you write the correct commands to retrieve those data as well. That's important to understand. And when you're retrieving any data, each programming language could have different syntax as well. So that's also important for you to understand. So whatever you're reading in your entire year 12, it's not the universal one-on-one way of writing stuff, because as you learn more programming, the style of the code and syntax and everything will change. But the basic pseudocode logic will be the same, because you're trying to solve a problem, you define step 1, step 2, step 3, and that kind of method will never change. And it just for a one word or two marks questions, I can see that it's important to remember who the word algorithm comes from, the name of a Persian author, Abu Jafar Muhammad ibn Musa al-Khwarizmi. It's a long name, but he wrote who wrote a textbook on mathematics. and his whole name, the name, the algorithm word came from his textbook as well. And an algorithm that yields expected output for a valid input is called an algorithmic solution. That's very straightforward. And as I said before, every algorithm will have an input and output in order to complete a goal or a process. And it has these characteristics, which includes, being finite, being independent, being feasible, and also unambiguous as well, to achieve the required output. Okay, let's see more characteristics about an algorithm in a table. You can find this in your book, so I'm not going to go line by line. So I will give example of couple of them, which may be helpful. So as I said, the finiteness is an important one. You want to write a program in such a way that it will have finite number of steps. You can't write an infinite number of steps, because the computer program will keep on going in a loop, and it will not finish its task. So that's why it's very clearly called out. Definiteness. Okay, this is exactly what you want the computer program to do needs to be clearly called out in your logic, right? When you're writing a program, if you want to do addition, do addition, division, multiplication, whatever you want to do, it has to be very clearly defined with the correct variables and parameters as well. And the correctness is important. Yes, it should be error free. What does that mean? Make sure there are no syntax errors, there is no spelling errors, things like that is important for a program to run properly. And it has to be simple enough to implement as well as understand. Otherwise, for even some other programmer to read in future, it will be very hard. So make it very clear, and each and every step has got clear input and output, very clearly defined variables as well, and portable. So portable is about, should be generic, independent of any programming language. Yes, which is what I said. Algorithms are quite standard. It has to be generic, and once you have it generically write a pseudocode, then it's easy to then equally implement a particular that solution in using a particular program, like a Java or a C or Python, whatever you want to write it. It's easy to convert. And also it should be also have step-by-step directions, which should be independent of any programming code. So basically, just want you to understand is that when you're talking about algorithm, it is not the program itself, right? It's about these characteristics involved and what I explained before, and it has to be completely independent, irrespective of whatever program and operating system we are using, and it should have the clear step-by-step direction to achieve and complete the task. Okay, so let's move on to a quick again comparison between what is the algorithm as program. As I said, both are different, and program is basically an expression of algorithm in a programming language. That's a very important point. You understand that. And also an algorithm can be implemented using a OOPS method, right? Object-oriented programming approach, or any structured programming methods. And for a program, you can see always there will be a specific syntax, but algorithm is generic, right? There is no specific rule for algorithm writing, but you have some guidelines should be followed if you're a programmer when you're preparing for a solution. And the last point is pretty important. So algorithm resembles a pseudocode. I kept saying that all the time. Pseudo is like, it's a dummy code, right? Which can be implemented in any language, and program is more specific to your programming language, which again we spoke before. So I think it's good to memorize this table as well, so that if you get questions around that, you can easily answer this point. This slide, we are going to see more about the time, space, and efficiency related to an algorithmic strategy. Okay, so the efficiency of an algorithm is defined by the utilization of time and space. What does that mean? So the running time of any operation, right, is calculated by how many programming instructions executed per operations. What does that mean again? Is that let's say when you're issuing or doing a programming or writing a pseudocode for an addition of two numbers, um, there is always a time factor linked with it, and also a space linked with it, meaning there is memory space record to perform that operation, and also efficiency, how fast the machine can run, and how fast the compiler of the computer performs. And also the programming language helps to sometimes speed up some of these operation. And then volume of data depends on the type data you are using as well. If it's a high volume you're trying to do, and it takes time as well. So all these form of multiple elements of this will make it the efficiency of an algorithm to be successful. Time complexity is normally is given by number of steps taken by the algorithm to complete the process. You may need to do 10 steps to achieve an outcome, or you may need to do 100 steps to achieve that output as well, depending on the type of the problem you're trying to resolve. So accordingly the time will change, that's important for you to know. Same with the space as well. The space is the amount of nothing but the amount of memory record to run to its completion. So whenever when you're executing any program, it will have you take the computer space to do the calculation or to solve that problem. So it depends on the size of the problem. The space usage could be different actually. It also has a fixed and variable part. Sometimes the way you declared your variables can also make a big difference. Sometimes there are static variables, sometimes there are when I say simple variables, and there are also constant values you may use. Each one of them defines amount of space it takes from the memory of a computer. And efficiency, it's something important to know that it's based on different resources, right? For example, for a maximum efficiency of any resource usage, which is time and space, it's very critical, right? It's very important for a computer program. So the execution time of any program can depend on several factors such as speed of the machine, compiler, and other system software tools, because depending on the software used, sometimes the speed can vary as well, and the operating system of the computer itself. Like for example, you may be using a Windows platform, let's say, or you may be using a Linux platform. So there are different operating system a computer is running, as you know. And the programming languages, any language, depending on the language you are using, and the volume of data I mentioned. Sometimes you may be using millions of data to calculate something, or run a report, for example. So the time consumption may be high at that point too. So in summary, a best algorithm to solve a given problem is the one that requires less space in memory and takes less time to execute its instruction to generate an output. And a space-time or a time memory trade-off is a way of solving a problem or calculation in less time by using more storage space as well. So these are definitions you see in your book, but the main point is about the best algorithm is what, which always requires a less space in memory and less time to execute it. So I think when a programmer gets more experience in his or her career, these kind of factors will come into play, and they gain experience how to tune the code, tune the programming language they write to solve a problem, to consider the efficiency as well. So, and not only manually you can do it, there are a lot of softwares available today to help with that tuning as well. And sometimes computer programmers will calculate the performance time and then adjust the code they wrote as well. So, and hence that's how in practical world it is used. But it's important for you to understand that these factors are important, and in an efficient way of programming language execution as well. Okay, so we've got a couple of more slides to go. So see the asymptotic notations. To be honest, this one is in a in a real job and workplace, we don't even go to this level and use these things. But these are like sometimes basics. They think basics of computer programming, and they in your books these topics are covered. So I thought I'll put a slide on it. So instead of going in detail, I'm going to keep it very high level on this. You can read from the book as well, but I've called out all the key points for your revisions. Okay, first is what's the definition? Okay, what are asymptotic notations? They are languages that use meaningful statements about time and space. Again, they are also a little bit related to the time and space. And it is also used to describe the running time of an algorithm, how much time an algorithm takes for an input of n value. So these are mathematical way of expressions. Those days, that's how they used to do things, right? And they introduced a few concepts like bubble sort and stuff like that. I will talk about the sort in the next slide. But things you have to just memorize or remember is there are three types of asymptotic notations. And what are they? They are below. They're big O, big omega, and big theta. So you just need to know the description on each of them. That's all. I think it's enough for this particular topic. Big O is actually, it's often described as the worst case of an algorithm, because if we want, let's say, for example, when you're trying to search a particular item in an array, okay, and it's got n number of values. Let's say there is 1, 2, 3, 4, 5, 6, 7, n could be, let's say, 100. So 100 values, n equal to 100 means you have 100 values. But then when you say O of 1, it will try to go find the very first element in that array, right? And between O of 1 and O of n is the worst case, since the complete list needs to be searched. So when a computer is getting a command to do the get me a O of 1, it will try to go to search the whole list and then get you the answer. So O of n is the formal way to express the upper bound of an algorithm running time. And this particular way of searching may sometimes take time because it is actually searching the whole thing end to end. So that's one thing to think through. Big omega is actually an opposite to big O to describe lower bound of worst case or best case. So I believe this particular method will search faster than the big O. And then the big theta is like an average. It's between both the last two types. In the range it will within which the actual time of execution of an algorithm will be. So it will go between a range of the theta of n of log. So theta is nothing but n of log n. This in mathematics term, which means running time of that algorithm always falls in n log n is the best case and worst case scenario. So it's a mathematical definition of it. I wouldn't confuse further on this. Just say, okay, just assume that these are completely three different types which is used to search a value when you're running a program, and each one has its own speed. That's all. And just understand, memorize what's the meaning of each of them, and that should be good enough for now. But in real world, we don't go into this detail and then use in programming or anything. Again, I just want to call it out. Okay, so let's move on to the searching and sorting techniques. So this is important. I think this is where it's better to spend more time. So there are two types of search which has been exposed to you guys. So in the books, which is a linear search and a binary search. So linear search is a sequential search. Sequential means it goes in 1, 2, 3 in that order. It goes in an order, which is a sequential method for finding a particular value in the list. So first, this method checks the search element with each element in a sequence until desired element is found. So for example, let's say I'm writing a program to find a search letter A in a set of statements. So let's say I write a program like that. On what computer, when you have a linear search method, it will try to go check each one at a time in every word and then try to find the match criteria until the list is exhausted, right? they don't order it. It just goes in a sequential order. It doesn't do any smarts actually. But in a binary search, it's called half interval searching. It's another method of searching, and it's also called as half interval search algorithm, which finds the position of a search element in a sorted array. So this is a good thing. In this case, in a binary search, what is the criteria is that the list of elements in array must be sorted for binary search. What it does is when you issue a binary search command, related command, the computer will do a sorting first and then do the search. So when you do that, you will search faster, right? Because you kind of finding all the matching kind of sorted in a way is it is more relevant, and then you are doing a search and trying to get the result, so which will be faster than the linear search for sure. So that's something for you to understand. And the sorting side, okay, okay, what is sorting? Okay, now there are again three different types of sort used normally. First is the bubble sort, second is selection sort, and third is the insertion sort. Sorting means is kind of arranging, right? Arranging something in an order. So let's say if I have a command of sort 1, 2, 1, 3, I don't know, 2 in an order. So the answer can come as 1, 2, and 3 because the computer should sort in an ascending order, let's say. So then it should actually give you an answer of 1, 2, 3, right? So in case of a bubble sort, what it happens is it starts at the beginning of the list of values stored in an array, and it compares each pair to the adjacent element and swap them. So it does the swap in next to each other as it goes, compares every value. Okay, are you bigger than me or you are lesser than me, depending on what you're trying to do here, and then keep swapping it. So though it is simple, it's a slow process because it's doing with every value in the array until it finishes to the last value in the array actually. It will get the answer, it will give the answer finally, but it could be definitely slower than the selection sort and the insertion sort. So selection sort is good, but it improves the performance mainly because it makes only one exchange for every pass through the list. So it actually scans the whole list together and then decide which one I'm going to bring it rather than checking one at a time. So what it will do is it will find the smallest elements in the array and swap it with the element in the first position of the array actually. Then it will find the second smallest and so on. So basically it repeatedly selects the next smallest elements and swaps into the right place for every pass. And hence it's compared to bubble sort, it needs only minimum number of swaps in general. Again, you won't feel this as a programmer, you don't feel all this, you won't even be able to see it, but the way you feel it is through the performance and efficiency of the results. That's how you will know, okay, this sort is working faster. Then the insertion sort is actually also simple, but it uses mathematical logic. It uses n minus 1 number of passes to get the final sorted list, because it knows it will take the value and then it will insert it in the right place as well. It does an insert operation, and hence it is called insertion sort. And it uses, as I said, n minus 1 number of passes to get the final sorted list. So compared to bubble sort, both the sorts are quite faster. And again, every programming language will have different commands to use this type of sorting as well as searching as well. Outside that, you will not know how this is all working unless, as I said, you see the speed of it, and the results what you're after will come faster by using one or other sort. Okay, so I think that should be good enough for knowing about search and sorting techniques in general. Let's move to last slide. I believe this is the last slide. This is about the dynamic programming, and it's an algorithmic design method that can be used when a solution to a problem can be viewed as a result of sequence of decisions. So this is about, okay, let's say you're doing some program, when you're writing a code and then there is some answers coming, and using that answer there could be some other things may be happening in the program. So as it decisions, from there you make decisions. Oh, if this value has come as I don't know, just x is equal to 10, then do this, just an example. So that kind of on, as you write the code, there will be dynamic branch out happening, and it will create and it will get divided into similar sub problems, which will in turn provide results and can be also reused to complete a particular process. So and also this helps to divide a small problem into a small overlapping sub problems. And what is the benefit of that? Means you do, it helps to make the program faster. Again, come back to that speed and efficiency of a program. And they're also called as, it's something for you to know and memorize, is that dynamic algorithms uses memoization. It's also called as memoization as well. However, you use the similar spelling, except S and Z are the difference. It's nothing but what is a memoization? Is an optimization technique used primarily to speed up the computer programs by storing the results of an expensive function's calls. What is expensive? Which is it is a function which takes long time to process and produce you a result, and returning the cached result when the same inputs occur again. So when you have written a function which we know it's got an answer, but then in another subprogram you may be calling that function. So what will happen is, in the first subprogram will be storing that answer in a cache, so that the function don't need to be rerun again, which will save the time and help the speed of the overall program execution wherever you're calling from. So that's kind of things you will when you're becoming a senior programmer, or you become more experienced programmer, you will naturally build such type of programs actually. So I must say most of the programming, especially complex programming, will have dynamic programming method followed, because otherwise it's impossible to produce a very efficient program. So again, just remember what is a dynamic programming and how it's used, and what does memoization mean, and I think that should be helpful. So in summary, I think these are fundamentals of algorithmic strategy so far, whatever we have seen. So with that, unit 1 of is finishing, and I hope all the 4 chapters were clear and helps you mostly as a revision. So I'm going to work on and produce the next set of series of videos for 4 more chapters, and this time fully focused on core Python from unit 2. Okay, so hope to see you all in another video soon. Until then, you all have a good day and take care. Thank you.